Okay, so for example, use the sum and difference formulas. So use the sum and difference formulas. Sum and difference formulas. To evaluate the following. Okay, so number one, let's do cosine of pi over 12, cosine of pi over 6, and then let's do minus sine of pi over 12. Times sine of pi over 6. That's a 6. It doesn't look like a 6, but it's supposed to be a 6. Okay, so let's recall. This looks like a cosine because he puts himself first. So, and I know that cosine also changes the sign, so I claim that this is cosine of a sum. And namely, cosine of a sum is cosine the first, cosine the second, and then change the sign to a negative, sine the first, sine of the first, sine of the second. Okay, so rewriting what's given, we have cosine of pi over 12. Let me color code, times cosine pi over 6. Why do my 6's look so bad right now? 6, and then minus, let me do that in red, minus sine of pi over 12 times cosine of pi over 6. Sorry, sine of pi over 6. Okay, so I claim that this is going to be cosine of the first angle, pi over 12, plus the second angle, pi over 6, because cosine changes the sign and puts himself first. Okay, so do you agree that that'll be cosine of pi over 12 plus, well, multiplying top and bottom by 2, that's going to be 2 pi over 12, which gives me cosine of 3 pi over 12. Well, 3 goes into 12 4 times, so this is cosine of pi over 4, which of course is square root of 2 over 2 when rationalized, right? Okay, and that's a 4. Why do all of my numbers look bad? Okay, that's supposed to be a 4. Okay, so let's do another one using the sum and difference formulas. So number 2, let's say we're given sine of 5 pi over 12 and cosine of pi over 12, and then minus sine of pi over 12 cosine of 5 pi over 12. Okay, so let's recall. Since this has both sine and cosine in each term, I know it's a sine. And since sine corresponds to the SIGN, this should be first minus second. So this sine of alpha minus beta was sine of the first, cosine of the second, minus cosine of the first, sine of the second. Okay. So we have sine of one angle, 5 pi over 12, times cosine of a second angle, pi over 12, from which we're subtracting. Let me change the order here. I'm going to write this as, where am I? Cosine of 5 pi over 12 times sine of pi over 12. And do you agree that multiplication is commutative? It doesn't matter which order I multiply in. So this should be, according to my formula, sine Actually, let me change the color. So this should be sine of the difference, right? The first angle being 5 pi over 12, from which I'm subtracting the second angle, pi over 12. So since these have a common denominator, I just need to do 5 minus 1, which is 4. So this is sine of 4 pi over 12. And of course, 4 goes into 12 3 times. So that's sine of pi over 3. The y-coordinate at pi over 3 is root 3 over 2. Okay, let's do another one using the sum and difference formulas. So number 3, let's evaluate sine of pi over 9, cosine of pi over 18, plus cosine of pi over 9 times sine of pi over 18. Okay, so once again, I notice that this has both sine and cosine in each term, meaning I know it's sine. And sine has corresponding angles, or SIGN, so this is sine of a sum. And we know that sine of a sum is sine of the first times cosine of the second times cosine of the second angle plus cosine of the first angle times sine of the second angle. So rewriting, what I have here is sine of pi over 9 times cosine of pi over 18, to which I'm adding cosine of pi over 9 times the quantity sine of pi over 18. Okay, so according to the above, this should be sine of the sum of the first angle, pi over 9, and the second angle, pi over 18. Okay, so in order to get a common denominator, I need to multiply pi over 9 top and bottom by 2, so that's 2 pi over 18 plus 1 pi over 18, and 2 plus 1 is 3, so I know this will be sine of 3 pi over 18. 3 goes into 18 6 times, so this is sine of pi over 6, which is 30 degrees. So the y-coordinate is 1/2. Agreed? Okay, so let's consider what if I wanted to find what tangent, what color should I use? Let's do green. Tangent of alpha plus beta. Well, I know that tangent is the quotient. Sine of alpha plus beta over cosine of alpha plus beta. And now I know how to expand each of those. Sine of alpha plus beta is sine of the first, cosine of the second, plus sine of the second, cosine of the first, or vice versa, all over. There's a reason I did it that way, just bear with me. It's a product, I can swap the order. Now cosine puts himself first, cosine alpha, cosine beta, and then he changes the sign, so this will be minus sine alpha, sine beta. So what I'm going to do in this quotient is I'm going to divide each term by cosine alpha, cosine beta. So that is, I will have sine alpha, cosine beta, to which I'm adding sine beta, cosine alpha, and I'm going to divide that by, actually let me do that in orange. I'm going to divide both terms in the numerator by cosine alpha, cosine beta, cosine alpha, cosine beta. And I'm going to do the same in the denominator. So I have cosine alpha, cosine beta, minus sine alpha, sine beta. So whatever I do in the numerator, I have to do in the denominator. So basically I have to divide all four terms by the same quantity, namely cosine alpha, cosine beta. Okay, so what happens in the numerator? It looks like cosine beta reduces in the first term, and cosine alpha reduces in the second term. And in the denominator, it looks like everything reduces in the first term, so cosine alpha and cosine beta. Whereas in the second term, nothing reduces. Okay, so what do I get? In the numerator, it looks like I have, actually, I still have a complex fraction. Let me move that down a bit. So it looks like I have sine alpha over cosine alpha for the first term in the numerator, plus second term in the numerator looks like sine beta divided by cosine beta. Now in the denominator, the first term reduces to 1 minus, well, what do I have? I'm going to write this as sine alpha over cosine alpha times sine beta over cosine beta, because sine over cosine, of course, is tangent. So I claim that I can rewrite this when all is said and done as tangent of alpha plus beta is going to be equal to, well, this first term in the numerator is tangent of alpha, plus this second term in the numerator is tangent of beta, all divided by 1 minus, well, this first factor is tangent of alpha, times this second factor is tangent of beta. So I claim that this is one identity for tangent of a sum. Okay, now let's consider tangent of a difference. So let's recall tangent of a negative angle, because he has sine in the numerator, is minus tangent of an angle. That is, tangent is odd. It has 180 degree rotational symmetry. Okay, so let's note then. If that's true, then tangent of alpha minus beta can be written as tangent of alpha minus a negative beta. Okay, so that's going to be the quotient tangent of alpha. Sorry, what am I doing? Plus a negative. So plus tangent of negative beta all over 1 minus tangent of alpha times tangent of a negative beta. So factoring out the negative in each instance of tangent of negative beta, the numerator now becomes tangent alpha minus tangent of beta, because tangent is odd, divided by 1 minus a negative, or 1 plus tangent of alpha times tangent of beta. Okay, so let's formally do these. So sum and difference formulas. Difference. Formulas for tangent. Okay, oops. So the first formula is tangent of a sum, alpha plus beta. So remember, sine is in the numerator and sine corresponds in sine. So that is, I'll have tangent of alpha plus tangent of beta. And he has cosine in the denominator, which is the opposite sign. So this is 1 minus the product tangent of alpha times tangent of beta. So let's note that the sine in the numerator corresponds, much like sine does, whereas the sine in the denominator is the opposite, much like it is for cosine. And the same holds true for the difference. So tangent of a difference, tangent of alpha minus beta, corresponds in sine in the numerator. That is tangent of alpha minus tangent of beta, and opposes the sign in the denominator. So this is 1 plus the product tangent alpha, tangent beta. So let me note that again. So now we have corresponding signs in the numerator. Actually, that doesn't look very nice. Corresponding signs in the numerator and opposing signs in the denominator.